In this video, we are going to learn how to graph the experimental data and identify the relationship between the independent and the dependent variables. And then you need to do some calculation to manipulate one variable and then produce a straight line graph. Okay, so in this assessment 2.1, okay, so there are 4 nonlinear relationships you must be familiar with. Okay, so when you draw your data, raw data from your experiment, okay, so you will see one of the 4 different curve or different shapes of relationship. Okay, so the first one is we say y equals to x squared. Okay, or we can say y is proportional to the x squared. Okay, so if we write in orders, we will be right y is proportional to the square of x, to the square of x. Okay, and the curve looks like this. Okay, and highlight this one. So this is an upward sweeping curve. Okay, so this is our first relationship. The second one is y equals to root x. Okay, or we can y is proportional to the square root of x. Okay, and the curve looks like this way. Okay, and highlight this one. So this is a curve that rises steeply, then flattens out. Okay, so this is our second relationship. And then the third one is y equals to 1 over x. Okay, so in order we say y is inversely proportional to x. Okay, so y is inversely proportional to x. Y is inversely proportional. Y is inversely proportional to x. Okay, the other way you can say this one would be y is directly proportional to 1 over x. Okay, so this means the same thing. Okay, but we like this one better. Okay, we like this one better. And the curve looks like this way. Okay, so we can say it's a curve that drops steeply and then flattens. Okay, as you move along the x-axis. Okay, the last one, okay, the fourth one is y equals to 1 over x squared. So it's y proportional to 1 over x or x squared. Okay, so you can say it's inversely proportional to x squared, or you can say it's proportional to 1 over x squared. Okay, and the curve looks like this one. And as they said, okay, this is very similar to 1 over x. Okay, so you can try 1 over x if you are not sure. Okay, but if you try 1 over x and you do not get a straight line, then you need to do this one. Okay, 1 over x squared. Okay, so this is the first thing. Okay, the 4 type of relationships. Okay, now let's look at an example. Okay, so we have a stationary ball begins to slide down a slope. Okay, and the distance it travels is measured at the specific times. So what does that mean? Okay, that means when it is 2 seconds, you check the distance. Okay, and 4 seconds, you check the distance. So that means independent variable is what? Independent variable will be time. Okay, and the dependent variable will be our distance. Okay, so when you go to the graph, okay, Okay, time will be in the horizontal axis. Okay, and distance will be here. Okay, and now you need to decide the range. Okay, so we are from 0 to 12 seconds, so we can see, I think if 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so this is our time. Okay, for distance is from 7 to 254. So by checking here, if we make here 100, 200, here is 300. So that will be 50 here, 100 here, 150, 200, 250, and 300. Okay, so this is our scale. Okay, and then let's draw the graph. Okay, so at 2 seconds and it is at 7, so 2 and the 7 is roughly here. Okay, nearly 10. Okay, and 4 to 28, so it's about 30. So 4 is here, and about 30 is, use the ruler, so it is here. Okay, and then at 6 seconds is 62. 6 is here. Okay, 62, about here, so it's roughly here. Okay, and 8 seconds, 112, so 8 going up, 112, about 110. Okay, so it's roughly here. Okay, and then 10 seconds, it is at 176. So 10 seconds, it is where? 176, 60, 70, nearly 80. So nearly 80. So it's roughly here. Okay, and at 12 is 254. So 12 is here, 254. So slightly higher. Okay, so this is our raw data. So you can, as you can see, it's here, 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 here. And when you draw the best fit, okay, the best fit, what can you draw? Change the color, light green, so you can see it's like this. So how will be this relationship? Okay, so this will be our relationship. And sometimes you might be, you're not sure. Okay, so you can get a hint, okay, from the formula they give us. Okay, so anyway, okay, the relationship is y proportional to x squared. Okay, and the hint that we can get from the formula is here. Okay, this is the hint that we can get from the formula. Okay, so you will see this is d and this is t squared, so will be the square proportional to the t squared. Okay, so now we finish the first task. Okay, you draw a nonlinear relationship. Okay, okay, now we finish the first task. Okay, so we know d is proportional to t squared. So how can we do the calculation and make the linear data? Okay, so from here we need to do what? Times square, t square. Okay, so t square, we need to make a t square. Okay, so t square times square, 2 square will be 4. Okay, 4 square will be 16, 6 square will be 36, and 8 square will be 64, 10 square will be 100, and 12 square will be 144. Okay, of course we can put 0. Okay, but this is not that important at the moment. Okay, so t square. So when we are doing the diagram, you need to know, okay, the horizontal axis is normal just the time. Okay, it's time square. So we need to make time square, or you can write say t square, and the unit will be second square. So this is the first thing you need to know. Okay, now we check the range. Okay, let's check. It is from 4 to 150. So if we want to make this one, it's only 12. So we will make what will be a good range. So if we try 10, 20 is only to 120, not enough. So 10 is not good. Okay, so if we try 20 here, 20, 40, 60, 80, 100, 120, 144, 160. Okay, I think roughly okay to here. Otherwise, we won't have enough space to cover all. Okay, so we use this space. Okay, and the distance is not changing. Okay, distance is not changing. So again, so here is 50, 100, and 150, 200. Okay, and this will be 250 and 300. This is the same one. Okay, so now let's do the graph. So the first one is t, 4 and 7. So this is our new data now. So t squared equals to 4, and distance is 7. And where is 4? Where is 4? 4. So 10, 20 there, 10 here. So 4 is roughly here. 4 and 7 is very close to here. Okay, 4 and 7. And then is what? 16 and 28. So 16 is here, and 28 is roughly here. Okay, and then will be 36 and 62. So 36 is roughly here, and 62 is slightly higher. 62 is here. 36, yeah, okay. And then 64, 1, 2, 64 is here, and 112 is here. Okay, and then what? 100 is 176. 100 is 176, nearly 180. So it's here. Okay, and then 144 is 254. 144 is roughly here, and it's 254, slightly more is here. Okay, so this is our new diagram. Okay, so if I use I use ruler. Okay, and I can get the best fit line. It looks like a straight. Am I right? Okay, so we can make the probably red. Okay, so this is our best fit line. Okay, it's a straight line, as you can see. Draw, I don't know, ruler. Okay, so by doing that, okay, by doing the time square, okay, and you draw a new diagram. You draw a new diagram. Here is t square, and here is the distance. Okay, and you have our straight line. Okay, so by showing this, okay, we completed the two tasks. Okay, so you compare the raw data. Okay, you identify the relationship. You manipulated one variable, and then you produce a straight line. Okay, hope you enjoy this one. Okay, thank you.